Now let's talk a little bit about the ozone hole. What is the ozone hole? The ozone hole is a region of reduced ozone concentration over Antarctica. So let's take a little bit better look at what the ozone hole means. So you may not realize this, but your whole life you've been fed propaganda about the sun. Usually when we think about the sun, here's how we have it on these stickers over here that I have. The sun is a loving, smiley face that loves us and cares about us. No, the sun is actually a giant, angry, vicious star that's belching out not only things like visible light, which we need in order to survive, but things like gamma rays, X-rays, and UV light. And the reason that we're worried about this light is that these are all shorter wavelengths of light. And they can cause everything from increased aging to cancer to even kill or reduce the function of many single-celled organisms on our planet that we depend for the base of the food chain. So UV light is the one in particular we're worried about with the ozone layer. So let's take a look at the layers of the atmosphere and how they protect us. So the top layer of the atmosphere, the thermosphere, protects us from most of these really vicious guys. That's why the thermosphere is called the thermosphere. It's so hot because it's absorbing, it's doing the heavy lifting of absorbing these gamma rays and X-rays that the sun is constantly belching out at us. Now, the UV light actually penetrates more deeply into the atmosphere and is absorbed in a layer of the atmosphere called the stratosphere. So right now, we're in the troposphere. We're in this bottom layer right here. This is where weather happens. The stratosphere up here is where we have this ozone layer right here. Why don't I color that in a little bit to make it a little clearer? So there's a concentration of ozone that peaks inside the stratosphere right here. And we're not talking about a whole heck of a lot of ozone. We're actually only talking about a few parts per million, okay? And the thing about that ozone is that it absorbs UV light. So like we talked about in the discussion about CO2, different gases and different substances absorb different wavelengths. So I have this cute little demonstration here. Here I have a piece of glass that I've smeared on some sunscreen. And sunscreen is supposed to protect you from UVs. Now, if I put this in front of the regular light, I can see I'm only kind of casting a vague shadow, and that's because I couldn't spread it on particularly thinly. This is actually a fairly messy thing to set up. But we only see a very vague sort of a shadow because it's not really blocking a whole lot of the full wavelength white light that we see. Now, I'm going to turn off the lights and bring back my UV light because black lights and dry eyes say science. Okay, so I've got my UV light here, and I can see I'm making the girl glow pretty intensely. But if I block it, this light, with the glass that's been coated with sunscreen, I can see that I can just basically turn it on, turn it off. It's blocking almost all of this UV light. So there's a couple of take-home messages from this, one of them being wear sunscreen. It's really valuable, and it actually works. It does block UV rays. But the other take-home message is that a substance can allow one form of light to transmit, like, for example, visible light, which is what we see with ozone, and absorb UV light. So what's going on? So what's the problem with the ozone layer? So the ozone layer covers the entire Earth. But where we have Antarctica, there's always annually a little thinning of the ozone layer because of Antarctic summer. And without getting too much into the chemistry, if you're interested in that, take my class. Or send me an email. I'm happy to explain it more in depth, but it takes a little bit. Basically, Antarctica is a giant mirror because it's coated with snow and ice, which reflects a lot of the sunlight back out. This breaks down the ozone even faster and causes a natural thinning of the ozone layer every year during Antarctic summer. The problem is that humans have been releasing something called CFCs into the atmosphere. And what this does, CFCs do, they're called chlorofluorocarbons. They're a group of chemicals that disrupt the formation of ozone. So in the natural world, what would happen is the ozone would break apart when sunlight hit it. It would form radicals, and those radicals would reform. Now, with chlorofluorocarbons in the atmosphere, it prevents that reformation of the ozone. And that causes a dramatic and unnatural thinning of the ozone layer, particularly over Antarctica, because Antarctica thins anyways. It gets exposed to an extraordinary amount of sunlight because of being a giant reflective mirror that gets basically 6 months of light a year during the summer. Once again, without getting too much into what's going on in Antarctica, it has to do with the amount of sunlight down there during the summer months, which is a tremendous amount that's reflected back out into the atmosphere due to the ice and snow. So the great thing about the ozone layer story, the whole ozone hole story, is that it's a happy story with a happy ending. Why? Because the ozone hole, the damaged part of the ozone layer, is healing. So why is it healing? Well, humans weren't happy with the situation. So we're releasing chlorofluorocarbons from the 40s, 50s, 60s, 70s, and scientists in the late 70s, early 80s noticed this thinning occurring. So what were we using these CFCs for? We were using them mostly for things like refrigerants, and if you've ever seen those crazy 80s hairstyles where hair was like super big and like standing out from people's heads, we used it for that too. We used it to make people's hair stand out. It was used in hairspray. It was also used in certain weapons. So humans, upset that this was happening, decided to take action. And a grassroots, in other words, ordinary people talking to each other and being like, hey, I don't want to have skin cancer, and I like tiny photosynthesizers in the ocean. I would like to save the planet. Let's stop these chemical companies from doing this through completely peaceful means. So it was this very remarkable, like when we look at today's world, remarkable way of handling a huge problem. People sat down and wrote letters to Dow Chemicals, which were making Dow Chemicals was actually making most of these chlorofluorocarbons. And Dow Chemicals actually read the letters. And Dow Chemicals actually voluntarily decided to stop making CFCs. So far, this is a big part of the story, are people just being honest with a company and not giving up, like not just saying like, oh, it's on Facebook right now, so I care. No, for years they wrote this company and they said, I'm telling my neighbors not to buy your company's products because you're making these CFCs that are destroying the ozone hole. And Dow was like, hey, it's bad for business and it's amoral and maybe we should stop. So they voluntarily decided to stop doing that. And the people didn't stop. They kept writing people. They wrote their governments. They wrote the UN. They staged a lot of peaceful protests. And eventually, the leaders of the world came up with this Montreal Protocol, which is the only UN resolution that's signed by everyone that says, yeah, we're going to stop using CFCs. We're going to stop making CFCs. And where we can't, we're going to try and reduce the production of CFCs. Now, another part of the story is that chemical companies had a sense that this was going to happen. So they started coming up with new ways to do things like refrigerants and hairspray that didn't involve CFCs. So by grassroots efforts, companies behaving responsibly, and governments actually acting like a bunch of grown-ups and working together to solve the problem, it now looks like the ozone hole is healing and will be completely healed by sometime between 2050 and 2070, which is pretty cool. a global problem was solved through united global effort. And I just want to leave you with that happy little story, because we usually hear about only the problems, and it sounds like everything's always getting worse. But a lot of things are getting better. I can give you a ton of examples of environmental problems that have actually improved. That doesn't make the bad problems disappear, but it kind of gives us a roadmap for how to solve them. I hope you've enjoyed these 3 little stories and 3 little scientific explanations of how these different environmental problems work. So I hope you enjoy in 250. Sign up for my classes.